Hey, GED students, super excited to do these problems with you because these are one of the formula problems that trick students. These are the kind of problems that make students tell me, I did really good, I felt really good. And then they come back and tell me I got a 144 score. And that meant they were getting tricked again and again. Here's one of those tricks. In fact, one of the GED test's favorite tricks. Let's take a look. It says a 48-foot grain silo has a diameter of 22 feet. To the nearest cubic foot, how much grain can it hold? So if you're not familiar with a grain silo, that's going to make this problem a little tricky. Like, we're definitely talking about a 3D shape, right? Because we're saying how much grain can it hold, but what 3D shape? There's a big clue in this problem. Even if I'd never heard of a grain silo, I can see that it has a diameter of 22 feet. That's a big clue that there's a circle going on here. But yeah, generally grain silos are cylindrical. They're shaped like these long tubes, cylinders with a circle on either side. And we see that it's a 48-foot grain silo. I'm going to assume that they mean height by that. And then it has a diameter of 22 feet. So what's a diameter? A diameter is a line that goes through the center of a circle from end to end. It goes all the way across a circle through the center. And so that circular top of the cylinder, I'm going to label it with a diameter of 22 feet. And then it says to the nearest cubic foot, how much grain can it hold? So first thing that we needed to do was determine what shape we're looking at here. Okay, we're looking at a cylinder, but then the second thing we need to do is determine what formula we need. Go to the GED formula sheet, look at the 3D formulas, and you're going to see there's two formulas. There's an SA equals, and there's a V equals. So it takes a little bit of geometry knowledge here. So that's one of the reasons this is in the advanced level practice, to understand which one of these formulas to choose. So mark up your formula sheet, make sure you know this, print it out, mark it up. Surface area is what SA stands for, surface area. And surface area is the covering. If I wanted to know about like how much metal it would take to make my grain silo, how much metal to wrap around, or I wanted to paint the outside of my grain silo, but that's not what's happening here. Take a look. I'm looking at how much grain can it hold. I'm trying to fill it. And I can see that other clue besides holding, that we're talking about cubic feet. Cubic feet are 3D measurements. It's like we're filling this entire grain silo with little cubes. So those are both really big clues that we are looking at volume. So challenge number one, my advanced level students, you needed to try to figure out what shape it was and figure out which one of those two formulas we needed in order to find what they were telling us to look for. It wasn't obvious. So nice job. We're looking for the volume of a cylinder formula. Hitting up the GED formula sheet, that is V is equal to pi r squared h. Now, a lot of students, a lot of you guys, my advanced students, this is why you're cocky. You figured out that the grain silo was a cylinder. You figured out this is volume. You wrote down the right formula. You got so super duper excited. You're like, I remember everything Kate taught me. And this is what you mess up. Okay, so I'm going to write this one in red. Most common error here. Students would be like, okay, I'm looking for the grain it holds. So I'm going to find volume. V will stay V. It's a mystery. I like that part. That's a good part. Then they say, okay, well, pi is approximately equal to 3.14. Kate told me, the formula sheet told me that when I see pi, I can substitute in 3.14. Close enough. And that's right too. I agree. But here's where they go wrong. The R in the formulas that involve circles stands for radius, and students just autopilot and put in that 22 and square it. So this is a GED favorite or GED test favorite trick. They're going to give you not what you need. So don't give up, throw your hands in the air. Oh my gosh, there's no volume formula that involves diameter. Well, no, there's not, but you are expected to understand something about circles and their diameters and their radii. That's just the plural of radius, guys, radii. So let me just draw it out really quickly. because you advanced level students will not stick with me through Unit 3 geometry. I know how you are. You'll be done soon. So just real quick understanding, if you have a circle with its center point, the diameter goes all the way across, but the radius only goes from a center to the outside. So the radius is just half of that diameter, okay? The radius is half of the diameter. So if they give you that diameter of 22 feet, you need to half it. You need to divide it by 2. So we'll have the volume. Yes, that's what we're finding. And yes, we can call pi 3.14, but the radius here is not 22. It's 22 divided by 2. It's 11. And that's what we're going to square and then multiply by the h stands for height. So the height of this cylinder. And now you can see this is now a relatively simple problem if you got through those 2 complications of figuring out which formula when it wasn't obvious and not just assuming that they gave you what you need. I always joke the GED is not your mama, okay? They're not trying to give you what you need. They're trying to test if you have mathematical reasoning. So part of that is understanding that diameter is not the same as radius, and radius is not the same as diameter, but you can use one to find the other. But now I'm just going to type this whole thing into my GED calculator. I don't even need to show you on the screen because it's all straightforward. So 3.14 times 11, I open up parentheses, close it, and then square it by pressing the x squared button, open up parentheses with 48 inside, and I get a real big, ugly number, 18237.12. And this is simplified. It's done. The only thing left to do, which happens a lot with geometry problems, especially the ones involving circles, is see if I have any rounding directions. Let me take a look. 48-foot grain silo to the nearest cubic foot. There we go. Notice it's not a place. They don't say the 10th, the 100th. They're talking about a whole cubic foot. And so they want you to round it at the whole numbers. So we're basically just going to cut it off at the decimal. Consider the next number, the one you're about to throw away. Are we halfway through our digits yet? Is this big enough to matter? No, it's not. It's less than 5. And so I'll say that the volume is about 18,237 cubic feet. And since I'm too lazy to spell cubic feet, I'll write it like this. And careful when that little 3 is just floating, when that power is just floating on the feet. That's not math to do. That's me being too lazy to spell cubic. That says cubic feet. It's a mathematical abbreviation for that. Ooh, tricky. Let's look at the other 2. Now, I want my calculator for the next 2. You're going to want it too. So go ahead, go grab it. That last one wasn't too bad, but I want to show you the keys to press on these next 2. So next one says an above ground pool is cylindrical. There we go with cylindrical again, with a diameter of 4.2 meters. If you pumped 30 cubic meters of water into the pool, so there we see again that we have a cylinder, and there we see again that we are filling the pool, right? You fill the pool with water, and notice what we fill the pool with, cubic meters. So once again, we're looking at the volume, we're filling it of a cylinder. Okay, and then we want to figure out how deep the water would be to the nearest 10th. So above ground pool is often cylindrical. They told us it was cylindrical. And it says, again, that we have a diameter of 4.2 meters, and it's going to fit 30 cubic meters of water in the pool. That's its volume. And the question is, how deep would the water be if we do that? So basically, what's the height of the water going to be? I mean, we don't usually say the height of the water, we say depth, but that's the concept going on here. So once again, we're talking volume of a cylinder. I am going to bust out that volume of a cylinder formula, which is V is equal to pi r squared h, and I'm going to put in what I know. Now, again, now we even got another trick here that full students, make sure you put in what you know, not just randomly plug things in. Because take a look, the very first thing in this formula is a V. And we know V, we know the volume, that's the filling of our cylinder. The pool, the cylinder here, is filled with 30 cubic meters of water. 30 is the V. And yes, I should probably use this little wavy equal sign, which means I'm about to bust out an estimate. Should have used it in the last one too. It's okay, it's not that big of a deal. But I know that pi is about 3.14, approximately. That's why I wanted the wavy equal sign. I'm a mathematician. I'm a little anal about my equal sign. I don't want you to disrespect it. But that's what that little wavy equal sign just means. It's about 3.14. Now, times r squared. Remember what r stands for? It stands for radius. Now, clearly in this problem, I'm not given the radius. But am I given what I need to find the radius? Let's take a look. An above ground pool is cylindrical with a diameter. Yeah, I am. So I know the diameter. I know all the way across the pool. So I don't need a formula to figure out the radius halfway across. So the radius is just going to straight up be the diameter divided by 2. And you can do that in your calculator if you're feeling a little intimidated. But 4.2 divided by 2 is going to give us 2.1. And that's what I'll plug in for my radius. That 2.1 is being squared according to the formula. And then the thing I'm looking for here is the height, how deep the water is going to be. Nice. Next thing, it's now you can see that this time the numbers aren't all on the same side of the equal sign or the approximately equal to sign. We have numbers on the left. We have numbers on the right over there with the variable. Now the algebra is getting a little trickier. I'm going to have to solve for h. But a really good rule of thumb is before you start solving, simplify anything you can simplify. And it's really nice in this particular example because this whole expression here, that can all be simplified, right? We can do 3.14 times 2.1 squared, and we should. It'll make our lives easier. And I'm just going to do the entire thing in my calculator, so that I don't even have to worry about the order of operations. So 3.14 times 2.1 squared, and I get this long, ugly number. I'm going to replace that portion of my equation with 13.8474. And guys, even if you're too lazy to write it down, don't drop digits, don't round until the end, or you might mess yourself up. You might get a slightly off answer. Okay, round at the very end. Now, I still have my h, still have my equals, approximately equals in this case, still have my 30. And now I'm almost done. I can solve for h. That green, big, long green number right there is multiplying with h. So I will do the opposite. I will divide it away. And of course, I can do whatever I want as long as I keep my balance. And then nice little calculator trick here. You can just type the 30 divided by, and then you can arrow up to that long, ugly number that's still in your calculator and press enter to select it so you don't have to type it again. Avoid errors with like misreading a number, switching the order of numbers happens a lot. And I get 2.166 yada, yada, yada is equal to that height or depth in this case of the water. And now whenever you get long, ugly decimals like this, make sure you pay attention to see if there's any rounding direction. So let's see, how deep would the water be? Okay, we're doing to the nearest tenth of a meter, to the nearest tenth. So the tenth is 1 decimal place after. So we'll cut off after the tenths. We'll consider not the tenths place, the next number, the one we're about to throw away. Ask ourselves if we're halfway through our digits yet. Yeah, we're more than halfway, right? 5 would be the halfway point. And so this sucker is going to round up. It's higher than 5. And so instead of calling that 2.1, we're going to say we're closer to 2.2 meters high. Ooh. So volume, cylinder, not giving you what you need. I'm giving you diameter instead of radius. Let's look at the next one. This one, same trick, but it's going to have a slightly different outcome because of what they're having me solve for. Okay, a company wants to produce a 40 centimeter tall cylindrical water bottle that holds 3,800 or 3,800 cubic centimeters. To the nearest centimeter, what should the diameter of the water bottle be? So first of all, what 3D shape are we looking at right here? Well, they were nice. They told us it was a cylinder. And are we talking surface area, covering, or are we talking volume, filling? Well, where do you put the water on a water bottle? Do you put it around the outside or do you fill up the inside? You fill up the inside. And so if we're talking about holding water then we are talking volume. And again, you know, it says cubic centimeters, so that's another clue that it's volume. So nice. Definitely volume of a cylinder here. But look what it's looking for. It says to the nearest centimeter, what should the diameter of the water bottle be? Well, if you're looking for a volume of a cylinder formula with diameter, you're going to be searching a long time. It's not on that formula sheet. The only formula we have that involves volume of a cylinder finds the radius. So what we're going to need to do is a two-step process. We're going to need to use that formula to find what it gives us. It can give us the radius, and then use what we learn in order to find the diameter. Let's do it. Volume of a cylinder formula, again, is V is equal to pi r squared h. We'll plug in what we know, okay? So the volume is the filling portion, whatever's cubic, measured in cubic units, the water in this case. So it says it holds 3,800 cubic centimeters. So that's my volume. And that's going to be about equal to, you guys can just use a regular equal sign. I just feel guilty leading you astray. Abusing the equal sign with you. Okay, so 3.14 for pi. And then r squared. Do we know the radius? No, we don't. No one told us the radius, and no one even told us the diameter, the thing that we could use to quickly find radius. And so this is the unknown in our formula, r squared. Now I have this h kind of trailing at the end. Like, what's happening with this h? Well, see how these three things are shoved together? Pi, r squared, and h. All three of these things are multiplying. So this is another multiplier here. You might say, well, Kate, r is being raised to a power. Yes, r is being squared, but that entire r squared is multiplying with pi and h. So h, the height, it is a 40 centimeter tall water bottle. And so the height is how tall it is. It is 40 centimeters tall. Now this sucker looks a little tricky with the number on one side of the r squared and the other side of the r squared. But that key that we talked about, how all three of those things are multiplying, can save us time and effort. Now this isn't the only way to do this, okay? But I know that when three numbers are multiplying, I can multiply in any order I want. I can go ahead and multiply those two numbers together, because even though you're technically supposed to do exponents first, when you simplify, we're not affecting the r squared at all. That's just three straight numbers multiplying here. Since that square only applies to the r, I can go ahead and do this. But if it throws you, you don't have to do this as the first step, okay, you guys? You could just divide away both of those numbers, 3.14 and 40, right? We know that to get rid of something that's multiplying, we could divide. But I know that I can just multiply these two together to simplify up my equation. So I'm going to do that. 3.14 times 40. And when I multiplied together this portion and this portion, I got 125.6, and that number is still multiplying with r squared, and that's going to be equal to 3,800. Cool. Now there's no more simplifying left to do on that right-hand side. Don't square that number, okay? That, like we said, that square only belongs to r. It's time to start moving backwards to work to get r alone. Now remember, when we solve, we actually work that order of operations backwards. So let's get rid of the multiplier before we get rid of the exponent. So that multiplier, 125.6, I am going to undo it by doing the opposite, by dividing. I can do whatever I want as long as I do it to both sides. And let's see what our new equation will be. Multiplying and dividing by 125.6 are opposites. They cancel. So all that's going to be left on my right-hand side is r squared. And that's going to be equal to whatever nasty thing I get when I take 3,800 and I divide by the number up above it. I just arrowed up because I'm lazy. And that equals 30.2, yada, yada, yada. Now, I'm not going to write all those numbers down, but I am going to leave them in my calculator because I don't want to round until the end. I can't even point that out enough. Don't round to the end. Don't round to the end. Please, for the love of God, do not round to the end. Okay. And it's not the end. A lot of students will tell me it's the end right now, but it's not, because careful, guys, r is not alone. Now, there's not a number hanging out per se. That little floating 2 is the signal of an operation. It tells us that that r is being squared. squared. So it's just the one number r, but it's being squared. And so I can undo that squaring by doing the opposite. The opposite of square is square root. And again, you can do whatever you want as long as you do it to both sides. So I'm going to square root the right and the left-hand side. Okay, square and square root cancel their opposites, leaving us with just r. And that's going to be approximately equal to whatever I get from square rooting the left-hand side. So to square root that long, ugly number without losing any digits, without rounding, I'm going to get the square root symbol first, okay? Now notice the square root symbol is over here, middle left, in green. You want something in green? Hit that green second key, and then you can hit for the square root. And now, again, I don't want to type out that whole ugly number, but I also don't want to lose information. So I'm going to arrow up to it, press enter to select, and enter again. And I see that the radius is about 5.5, yada, yada. Okay. Now, you are very likely to make the mistake that I was just about to make. I seriously just looked at this problem. I was about to round and walk away. And I'm doing this video so you don't just round and walk away right now. Why? I haven't done what the problem asked yet. I found out something neat, but what did I just find out? I just found out that this is approximately what the radius of this water bottle is. And this problem, it didn't ask me about radius. Look what it asked me. What should the diameter of the water bottle be? Right now, I know that the radius from here to here is about 5.5, but the diameter, that stretches all the way across. So a diameter is 2 radiuses. I'm going to have that number twice, 2 times. And so I need to, as my final step to find the diameter, multiply by 2. See how easy it is to just walk away thinking you did all the hard work and then get tricked by that little radius diameter relationship. All right, so the diameter then is twice the radius, and the diameter in this case is about 11 point yada, yada, yada. And now, and only now, I will round, because now I found what they asked me to find. They asked for the diameter. I found the diameter. So let's look for rounding directions. To the nearest centimeter, what should the diameter of the water bottle be? Okay, so to the nearest centimeter, once again, we're talking about whole units. So let's go ahead, round right at the decimal and say, okay, that's about 11 centimeters. Woo! You can see how we can take simple concepts on that GED test and just up our game by throwing in some calculator issues, some exponents, some decimals, hiding what you're looking for, not quite giving you what you need for the formula. Yeah, they're really trying to test y'all's math reasoning skills. So you guys need to be on point with that logic. On point. You got this. All right. Strong work, guys.